the feed actually starts. So welcome back. Doing a quickie today. So I just wanted to do a little bit of a redemption, as the title says, so you can see it. You know, as if you saw the last stream, my drawer is stuck for some reason. If you saw the last stream, I built this kit. This is actually the first kit that I've built on this channel that didn't work properly when I was done building it. So what happens, see if I can, whoa, oh boy, she's all finicky, there we go. So, hard to tell with my blinding lights, but what was going on is it only charges up to 50%, and no matter how long you wait, it will never get to 100%. So why is that? Well, that's gone forever. So why is that? Well, could be a few things. First thing that comes to mind, well, actually, to be honest, the first thing that comes to mind is these the windings. There's a resonance circuit in there that charges up the capacitor because it's a 100 volt. You can see, oh, it's upside down. You can see right there, it's a 100 volt capacitor, 1 farad. So to turn a couple of AA's into 100 volts, obviously you need something going on, and that's where this comes in. There's a couple windings for a resonance circuit to build the voltage up. So if you remember when I was building this kit, I'm looking for the distractions. I don't remember where I set them down now. Here we go. So if you remember when I was building this kit, when I was soldering in the leads for that for the coils, it looked to me like it should have gone copper, red, yellow, but I put it in, according to the instructions, copper, yellow, red, and that was the first thing that came to my mind, was maybe the trigger coil is backwards from how it's supposed to be. But then when you look at this, it actually seems like the yellow and red actually have the same amount of windings. I was pointing to the wrong thing. It seems like the yellow and the red, which is sorry, I'm getting ahead of myself. Yeah, the yellow and the red is L1 and L2, and they seem like they're the same length because they're part of the tank oscillating resonance circuit. So I don't think it matters whether I got one in L2, if I got yellow in L1 or red in L1 and vice versa. I don't think it's going to affect things at all because it's the same gauge wire, same number of turns. So we can roll that out. So what else could cause it? Well, the next thing that comes to my mind, cause it to not charge to 100%, by the way. The other thing that comes to mind is I'm using rechargeable batteries because, you know, the amount of batteries I went through, if I didn't use rechargeables, I'd be broke. So these are NiCads that focus more on the total capacity, not the voltage. As you might know, if you've ever dealt with rechargeable batteries, they all are a little less. Like these are 1.2 volts. It's pretty common. If you look at a regular disposable AA battery, it'll say 1.5 volts. So really what's going on here is I'm getting 1.2, so that'd be 2.4 volts. Instead of, if it was 1.5, it would be 3 volts. You know, it's kind of probably not, but that could cause it. It's totally possible. So to rule it out, I'm going to fire up my power supply just out of view over here. Let me set it. Oh boy, I'm getting them mixed up. Okay, so I'm going to set it to, what the hell? I'm going to set it to 4 volts just to really rule this out. All right. So it should be 3. I'm giving it 4, and I'm basically giving it unlimited amperage. We'll see what it wants to draw. Go ahead and turn this on. It's drawing 0.0, 80 milliamps basically at 3.99 volts. You can see clearly it's charging pretty good because now the lights that you could barely see earlier are now both very bright, but still, no matter how long we wait, the 100% LED isn't coming on. So now, oh, and now it's drawing 100 milliamps. So clearly there's something going on, but it's not charging like it should to its full potential. So go ahead and shut that off. Let me just discharge this. Oh, speaking of discharging, I totally forgot to translate the markings on the markings. I forgot to translate the words on the back here. So the bit here, let me get my pointer instead of waving my nasty fingers around. The bit here that's in between all the exclamation marks, that says high pressure or high danger, the high pressure hazard, which is, high voltage, high pressure hazard, high voltage hazard. And then the rest of this basically says something along the lines of, if you're going to take this apart or if you're going to touch anything on the circuit board, then you need to discharge the capacitor first. Anyway, so now when we got all of that stuff out of the way, my thought process here, right? So sure, I do kind of feel slightly compelled to try and diagnose the issue and fix what's wrong with this, so I can, be a little completionist about not having all the kits I've assembled have worked up until this point. So I hate to have this one hanging over my head, but this is, this is like a desk toy. I'm never really going to use this outside of the video I'm filming. So my plan here, I have, if you've ever seen any of my other videos, I've got these power supplies hanging out over here and amongst, all the other stuff, all the other potential projects going on. Can't even, honestly, I don't even remember what I bought those for originally, but I never ended up using them. So these, you can generate a couple, up to 400 volts, I think. It's a boost converter. So you put in 12 to 24, you get out a few hundred. And if you can guess where I'm going with this, I'll tune this to 100 volts or maybe like 105, 110 volts. So when I load it up, it'll come down to 100. And then hook it directly to that capacitor, and we'll forcefully charge that capacitor. Then we can see what it's like when it's fully charged and be like, ooh, it works. And then that'll be it for today's stream once I take care of that. But in the future, I'm going to come out with a video instead of a live stream where I replace this one capacitor with something a little more oomphy and design a way to charge it nice and quick. And that'll be the first modification. From there, I got this idea, right? I don't know how practical this is going to be, but I'm going to use the coils out of an ABS module. I don't know how many of you know what the inside of an ABS module looks like, but ABS module is a bunch of valves, and those valves are actuated by a solenoid coil. And to keep isolation between the hydraulic circuits and the electrical circuits, basically it's just like a water valve or an oil valve, any solenoid style valve, right? The valve that controls the fluid is this one part, and then there's a coil on the dry side that just kind of slips over that valve. That way you can have all the fluid down here sealed off from the electronics up here. And yeah, so long story short, I'm pulling all of the coils out of a ABS unit that's gone bad, or the valves have gone bad, but the electronics are good. So I'm pulling those coils out. There is 6, I want to say there's 9 coils in there. So I'm pulling them out, and I'm going to turn it into another electromagnetic processor, but one that has multiple stages, hence the multiple coils. And we'll come up with some cool stuff on how to drive it and control the timing and what's going to trigger each successive coil as the piece of metal is being processed. Anyways, I'm getting distracted. I just wanted to do a quick redemption stream here. So, the old power supply off screen is on. Yeah, I'll just so you know what's going on. There it is. So I'm going to set that to 12 volts to run the boost converter here, and of course the multimeter, which is perfectly blown out from the light. So you can see, what is it? Oh wait, yeah, no. Scared myself there for a second. I thought it was on resistance. All right, first I got to turn the power supply up to 12 volts. Turn it on. Now, what are we at? 131. Wow, that's so close. Where's my screwdriver? I'm going to go ahead and tune this bad Larry. I could probably, once I load it up, the voltage is going to fall off significantly. So I'm definitely trying to overshoot 100 volts, but by how much? I don't know. 6.3 is probably fine. 4.8. Now we're closing in. I could easily drop 5 volts, put the load on this thing. So, yeah, why don't we just leave it there? 105. I think that's fine. It'll probably end up being like 99, 98 volts once it's loaded. Okay, so now I need to shut the power supply off. Actually, I shouldn't have shut the meter off either, because there's, a couple hundred, there's 100 volts waiting to get me over here. So just put the meter on while we watch that drain. Down to 3, 2, 1. All right, less than a volt. I'll touch it. So, let's see. I got these ends on here. Oh yeah, right. So how are we gonna attach ourselves to the capacitor? Well, naturally we're gonna take this thing back apart, and that actually brings up, if I can get the screwdriver in the hole, and that actually brings up a whole nother thing that didn't even cross my mind when I was assembling this kit. If you saw the other stream where I built it, I was just talking about how these nuts are a little finicky, because if you get the whole thing assembled and then putting in this last bolt, you accidentally lose the nut through the hole. Then you got to take it all back apart. But actually, what for some reason I couldn't picture this in the moment, but if you just loosely thread the nuts on, so they're just at the end of the bolt there, then what you can do, wait, oh, I didn't undo it enough. Oh, I was about to make a fool out of myself here. There we go. Now I should be able to just pull this out. Oh man, there we go. All right, I knew it was possible. There. So now you can just put it in the same way, where you push it just to the side. There we go. And now you don't have to worry about losing the nut in there. So I was just, I don't know a good word. I was just being grumpy, I guess. I don't know. It's totally fine. It's fine. So, yeah. So my plan, boy, this is so finicky, but we'll do it. We'll do it. What am I going to use to attach to the capacitors? Well, I got these I still don't remember what these test clips are called, but I'm going to use them. You don't have to know what they're called to use them. All right. Oh, oops. I mean, I get my face all up in the camera there. Oh man, is this really too steep of an angle? Nah. We'll figure it out. Don't you worry. Wow. I'm kind of blown away, to be honest. I thought this would take me 2 seconds. There we go. That's how I imagined it would go. Alright. It's a theme on this channel. Oh, that'll take me X amount of time. Turns out it takes Z amount of time. Anywho, go ahead and get this just kind of limply back together. Whoop, whoop, whoop. All that talking, now I can't execute the plan. Gotta stick to the plan, man. There we go. Get that one in. Now this one's gonna be finicky. Ooh, baby, look at that. Okay, and nobody breathes. So the thing here is that obviously we're working with a slightly elevated voltage. 100 volts is not what I would consider too dangerous, but I don't want to touch it if I don't have to. So just wanted to make sure no wires are touching any part of the circuit in there. Now, we've got to very carefully observe. Hopefully I didn't mess this up. I think I did. Negative is on that side. Oh, I didn't. Sweet. Yeah, I forgot to mention that there's specific leads. So I got the DuPont connector on this one and alligator on the other one. Then that way I know, because the alligator is positive and it's hooked up to the positive on this. Anyways, I'm rambling. Let's get this thing cranking. So what am I going to fire at once we charge this bad boy up? Well, actually, why don't we make sure we even can charge this up before I get ahead of myself? So crank on the power. We should see. Oh, yeah. Oh, yeah. Boy, I don't know if my microphone picked that up, but this thing is screaming it charged so fast. Let's just dump that. Oh, yeah. Let me move my mic in while I charge it up. Power is on. Yep. Oh, yeah. She'll take a charge. All right. She'll take a charge. No complaints. Okay. Let me just get my mic back in place. So again, what am I shooting at? I don't know. I should have bought a really cheap, should have went to the dollar store and got a cheap picture frame so I could dramatically break some glass. Ooh, holy, speaking of breaking glass, God, get these neon tubes out of there. Talk about dramatic. That would be very disappointing. Okay. What am I going to shoot at for the 18th time? I don't know. What? Prepare? What's prepare? All right, there we go. I'll shoot at the destructions again. Destroy the destructions. Okay. Let's charge her back up. Screech. Reet. Okay. Fire at will. Whoa. That's a little better. And it charges so fast. I mean, charges to 100% with my setup faster than it gets to 50 with the original. Woof. She's got some aggression too. This is very interesting. We're watching the current. It keeps jumping up to 300 milliamp, and then it falls off to 20 milliamp, and then whoop, back up to 300. Must be some leakage going on somewhere, but anyways. So there you go. It works. Boop. And ooh. I don't mind. I'm imagining things. I thought it was getting hot. But yep. So there you go. Whoops. Oh boy, we're gonna do this again. Guys, come on, it's me. All right, there we go. Well, that about does it for the electromagnetic processing kit. We came, we saw, we applied, we were disappointed. Next time, I'm gonna put. Honestly, I'm not sure what direction I'm gonna go in. I got a bunch of these 1500 microfarad 80 volt caps. To be honest, I don't know if that's really gonna be much better. I was thinking that maybe I should go for a couple 100-volt caps around a farad, 1.5 farads, like that, and string them in series or parallel. Figure out some way to get a little more oomph out of this thing. And then once we reach the maximum that these coils can handle, then of course I'll go on to the ABS project that I discussed. But anyways, I'm rambling. Wanted to make this one quick. We'll catch you next time.